So today we're going to look at how you actually do some calculations in a matrix, and we'll also look up on plotting. This is a way that you'll be using to represent your data or represent answers. So just quickly, we looked at creating matrices. So there's a few different ways that we use to create matrices. So for instance, you can use the direct input method. So you put a square bracket and you write each of the element of your matrices one by one. So when you're doing the direct input, you have to use square brackets. This method is mainly used when you're trying to input a matrix that has random numbers, that they are not evenly spaced, etc. Because there's only one way to do that, is manual input. However, if there's some form of a repetition, or there's like an equally spaced data that you're trying to input, you can use the colon operator. You can even use linspace if you want to space out a set of data using X amount of points. We also looked at using this apostrophe sign. So this is to transpose a matrix. So the MATLAB default, if you create A equals to 1 colon 5, it will create a row matrix that has numbers 1, 2, 3, 4, 5. Using the transpose, we'll convert that row vector into a column vector. You have the semicolon notation as well, where you can specify the increment. So the default of MATLAB is 1. If you want it to be anything other than 1, then you specify it. So linspace, as we said before, will split a set of data equally from the start to finish using n number of points. So in this case, the limit of the data will go from 0 to 4, and it will have 5 points, including 0 and 4. So in this case, 0, 1, 2, 3, 4. You also have matrix addressing. So if, for example, let's say we have a matrix A. So it's a 3 by 3 matrix. So you're given 3 rows and 3 columns. You can pick numbers from the matrix. You can even pick a sub-matrix from that matrix. Few of the notations that you use, when you're picking a number or even a range of numbers, the syntax for it is you have the name of the matrix. In this case, it's A. Then you have the round brackets, and inside the round brackets is where you're going to call whatever number you want. The syntax to call it is row, and then you have the column. So the first line, we have A round bracket 3, 1. That means we are going to pick the third row and the first column. So we'll pick this value. Okay. The second line, when you use the semicolon notation in the section where you're supposed to input the row, what MATLAB will do is it will pick all the rows of that matrix. So in this case, the second line, it will pick all the rows, so all the rows, but only the second column. So it will pick those values. N, N will be the last row and the last column. So you can use AND if you want to get the last row or the last column. So the third one here will pick this value. Okay? So when you do matrix calculations, so just like you have with a normal vector or a normal scalar, I should say. So if you have A equals to 3, B equals to 2, you can do A plus B, which means it will be 3 plus 2, 5. When you have a matrix, you can also do calculations to the matrices. So for example, you can do addition and subtraction just as you would do on a scalar. So if you have 2 matrices, let's say you have a matrix 1, 2, 3, and 4, and you add that to 4, 5, 6, 7. So that will give you So 1 plus 4, 5, 2 plus 5, 7, 3 and 6, 9, 7 and 4, 11. Okay, so this is your basic addition and subtraction. Whenever you're doing matrix calculations, the one thing you have to be very careful is your matrix sizes must be the same. So for instance, this and this must have the same size. If they're not the same size, then you won't be able to do the matrix calculation. So when you try that in MATLAB, you will see if it's the wrong size, it will give you an error. So that's the basic rule of doing matrices. Okay? They must be the same size. The same size means same number of rows, same number of columns. Okay? When you do multiplication and division or exponentiation power, this is where it gets tricky. So have you guys done matrix multiplication before in maths? So what you would have done, if you've done matrix multiplication before, so if say you have 1, 2, 3 and 4, and then multiply by, let's just say 5, 6, 7, 8. So what you would have done in mathematics is you take the first row, multiply by the first column. Yeah? And then you take the first row, multiply by the second column. Then you go to the second row here, and again multiply by the first column and multiply by second column. And your answer will be like a 2 by 2 matrix. This is normal matrix multiplication that you would have learned before. However, what we are doing here is not really like using matrix multiplication, but mainly we are storing data in a matrix form. So we're using the matrix to store data. If we want to do multiplications, so let's say we have 1, 4, 5, 6, 7, 8. If we want to multiply those two matrices, whereby we want the first element of matrix A to multiply with the first element of matrix B, so let's say we want to get this answer. Second element of A multiplied by second element of B, and so forth. So if that's what we want to do, so we want to get each element to multiply by the corresponding element, we need to use a dot in front of the multiply. So when you do the matrix multiplication, you need to use a dot operator. So let's just quickly try this out. So if I do the matrix 3 and 4, so that's A. I'll do B equals to 5, 6, 7, 8. Okay, so this is my matrix A and B. If I just do A multiplied, I call it C, equals to A multiplied by B. Okay, so I get 19, 22, 43, 50. This is like the usual matrix multiplication where you take a whole row, multiply by a column. However, if I wanted to get each of the elements multiplied by the corresponding element, then I'll do D equals to A, and then I'll put a dot in front of the multiplication sign. And that will give me my 5, 12, 21, and 32. So this is very handy. The dot operator is very handy when you're working with large amount of data. So you have like a number of time, a number of velocity. You need to do, for some reason, let's say you need to do time multiplied by velocity. So you want to get all the elements of the vector t multiplied by all the elements of vector v. So you need to use the dot operator. So it will get all of them one by one. The same work is when you want to do division. So again, if you recall, in normal matrix term, there's no such thing as division. Okay, there's only inverse. However, here what we are doing is we are getting element by element division. So once again, we use the dot operator. And exponentiation is effectively same as multiplication, because if you're doing x squared, is the same as x multiplied by x. So it's still a multiplication. So again, you use a dot operator. So you will tend to use the dot operator a number of times throughout this semester, because in engineering, or even for 1060, a lot of times you will be working with multiple data or data sets that contains more than one value. So let's say now, okay, if you want to represent, you have like an equation, so y equals to x squared minus 2x plus 1. So if you want to plot this from -5 to 5 with an increment of 0.5 in between the x values. So your first step, so this is you trying to plot a data, okay, plot an equation. So your first thing that you do is you need to create your vector x. So you can create your vector x in this format. So you're going from -5 to 5 with increments of 0.5. If this wasn't given to you, then it's up to you. You can decide whether you put it from -5 to 5 in increments of 1. You could even use the linspace. So you could have linspace -5, 5, and if you want 10 data points, you put 10. If you want 100, 100, or 1,000, it's up to you. So once you create your x, so you will end up with a vector containing x values. So now you want to calculate y for the corresponding x values. So you use the equation for y, but now you're doing x squared. So x squared, which is basically x multiplied by x. Because you want each element of x to multiply by each element of x, you need to use the dot operator. The next part is 2 multiplied by x. Now, 2 multiplied by x, in this case, you don't need to use a dot. So the rule here, when do we use dot and when we don't use dot? So, yeah? Yes, correct. So whenever you're doing a vector multiplied by a vector, which means element of one vector multiplied by corresponding element of another vector, or the same vector, if you're doing a square in this case. So whenever you're doing multiplication using two vectors, then you must have the dot. If there's only one vector involved and the other one is a scalar, so scalar is basically just one number, then automatically it will multiply all the elements. So in our case, 2 is just a scalar, just one number. So when you multiply by x, even though x is a vector, MATLAB will automatically multiply 2 to each element of the vector. Okay? So with this thing, when you do a few more practice questions, then you'll get the hang of it. But it is important that you understand when to use a dot and when not to use a dot. For instance, if you use a dot here, nothing will happen. It will still work. So overusing the dot will still work. However, you need to know when to use it, mainly for exam purposes. Because in exams, you could get questions that give you some scalars and some vectors, and give you like an equation to multiply and ask you to write it using the dots in the right location. So you need to do that. But again, this will be mentioned multiple times throughout the lectures this semester. So once you get your x and y, so now you have two values, x and y, you can plot that graph. Question? No. So if you want to plot the graph, so in MATLAB, the syntax for it is simply plot, and you write x comma y. So you write your x-axis first, and then the y-axis. So that's the syntax for MATLAB. So again, this is what we were talking about before, when you have scalars in matrix calculations. So MATLAB is smart enough to expand the scalar. So when you're doing 2 multiplied by x, it's the same thing as, now this looks weird, but effectively, if you recall, size of x will give you the size of the matrix, so how many rows, how many columns. Ones will basically make all of these numbers multiplied by 1, or you create a matrix with all ones in there. So it's 2 times 1's the size of x. So let's assume the size of x was 2, 2. So 2, 2 was the size of x. So 1's 2, 2 will give you a matrix that contains 2 rows and 2 columns with 1's everywhere. Now this multiplied by x will give you whatever the numbers of x. So I don't know, if x was, let's say 4, 6, 8, 9. So it will be 1, 1, 1, 1 multiplied by that using a dot operator. And then you have the 2 multiplied by that. So it's effectively the same thing. So MATLAB just does it for you. You don't have to see this, you just see that. Yeah?
Is there a different order of precedence for one with dot over one without the dot?
No, it works the same. So when you have the dot and all, it will still do like brackets, order and all first. So when we looked at the lectures last week, so we looked at a few of the MATLAB inbuilt functions in MATLAB. So the basic one was sine, cos, etc. You also have the square root and all. So all these, a lot of these MATLAB functions will also operate on matrices. So again, probably in your first lab, we looked at applying those square root or cos, sine to just one value. However, if you're working with multiple sets of data, then you can use the same functions for a set of data. So for example, if you have some angles, so in this case we have a vector containing 5 angles. So you can use the sine, cos, and tan of those, and MATLAB will automatically create a vector for you. So if you create the input here as a vector, the output will also be a vector. So notice here we are using the sine d, cos d, etc., because the angles are given in degrees. So a number of these, again, you will get a chance to try them out when you do the labs, or in fact, in your own study time. It's a good idea for you to try a few of the commands, just so you get familiar with it and how it works. So you have also some built-in functions that are specially designed for matrices. So matrices or vectors. Okay? When we say matrices, it automatically means vectors as well, because vectors is basically a matrix with just either one row or one column, but it still has multiple data. So some of these functions, like sum, mean, median, min, max, etc., have been designed to work specifically for matrices. So you put in a large set of data, because imagine if you had to write a program to calculate the maximum of a set of data. So how would you do that? You have to get the first data, and then you compare it with the second data. If the second one is bigger than the first, then you store that somewhere. And then you go to the third data. If the third is less than the second, you skip, you go to the fourth, and you go through all of your data points until you pick which one is the maximum. So this can all be done using a simple command, max. So if you recall, in the lectures on Tuesday, I showed you about this command, the min and max, and I also showed you that min and max can also return you the index of where it happens. So if, for example, in this case, if you use the max, so the maximum will return 42.5. You can specify your output. So instead of having just A equals to max, if you write it just A equals to max, because you specified only one output, by default, MATLAB will just give you the maximum value. However, if you specify two outputs, the function max or min has been written in such a way that when you specify two outputs, the first one will give you the maximum value, and the second one will give you the index of the maximum value. So here the index is 1, 2, 3, 4, 5. So this will return 3. So you know where in that matrix it happens. So you can have a play with that. You create my data, so which is a small matrix of 2 rows and 4 columns. So you can do the sum of my data. That will give you the sum. You can find the average by either doing the mean, or you can simply find the number of data points in the matrix and then divide that, or the sum divided by that. In this case, it's highly advisable to use the mean. So, yeah?
Does it sum both the rows together, or do you get the outputs?
You will sum both the rows together. Now, if we look at a problem-solving example, okay, now this is just a small example. I think some of these questions might appear in the labs. You might see them familiar if you've had a look. To actually calculate the sine, the way that calculators will do it is it will perform a Taylor series approximation. So Taylor series approximation, for instance, for doing the sine, it's this equation, which can be expanded into that. And this goes on forever. So it goes to infinity. So the number of terms that you have is infinite. However, the more terms you use, technically the more accurate you get. But when you go to that far, it all depends on how many significant figures or how many decimal places do you need your accuracy to be. Now, we won't get into too much details for this at the moment, but what you should understand from this part here is just that you have a Taylor series approximation, and you can do endless number of terms to get more and more accurate results. So more terms, however, means more processing. More processing means higher cost. Okay, that's the general rule of it. The more you're processing, it's higher cost of computational time, effort, etc. So if you're, imagine that we say here the example, your company developed a chip that calculates the first 2 terms of the sine Taylor series very quickly. Okay? Now imagine this is a chip that you are going to put in a calculator, a new calculator, and to do that operation, you're going to use only the first 2 terms. So if we want to know whether it works, so we have to compare it with something. So let's say we compare it with the default sine x that we get from a standard calculator, okay? Or like the old chip, for example. So first step, we create a row vector of x values. So we want to find a range of x for which we are going to find the sine of x. So we can create that between pi, negative pi and pi. Then we can do that calculation. Okay, so this is the calculation here. So this is for the term n equals to 0. Okay, so this is the term n equals to 0, n equals to 1, etc. So when you get the actual sine value, you add them together. So again, in this case, we are only doing the first 2 terms. So when we get to this set of data, so we have one value of sine for negative pi, and we have another value of psi for the 0.01 minus pi, etc. So you end up with 629 values in this case. To compare them, if we try to do that by hand, you'll see it's not a good thing. So what we do is we use a plot to visualize the data. So again, in engineering, you will find that very often you end up using plots to show your data. Because again, if you have 1,000 data points, it's very hard to go and read that on a spreadsheet, etc. So we plot the data, okay? Plot x, y. If we want to plot multiple sets of data, okay, the plot command, so again, if you recall, the syntax for the plot is the x-axis first and then the y-axis. This will plot one line, just one graph for you. If you want to plot multiple lines on the same graph, you can do that command. So the first line, you have the x and the y. The second line, you have the x and the y, and so forth. So then you can plot however many lines you want onto the same plot. So in our case here, we're trying to compare the results between the default sine x and the one that we've done using two approximations. So our one, we're plotting x, sine underscore approx. Okay, that's what we called it. And we want to plot the default value that MATLAB has. So we plot x, sine of x. So that's the graph that we get. The blue is our approximation, and the red is the MATLAB default one. So you can see that from about here to here, it's probably okay. Or it looks very, very close. However, once you get to those values, you're not accurate anymore. So again, what does that tell you? It's basically depending on which range of x you are going to use that chip. If the chip that you are using, let's say the chip that was being developed, would only be valid from -1 to 1, okay, just say for some reason, the only values or the only angles that it will ever calculate will be between -1 and 1, then using two terms is fine. There's no problems with that. However, if that chip was going to be calculating sine of any values outside -1 and 1, then you can see it's not good. So then you need more terms. So that way, you can create programs that are targeted for your specific application. Because if you don't need that much memory to calculate 100 terms, then you don't need to use it. You just allocate a little amount to calculate 2 or 3 terms. So that's just an example of where it could potentially be used. When you are plotting data, okay, it's also good that you can represent your data clearly. So you can represent different colors, different stars. So in MATLAB, you have a range of colors. Again, if you look onto the MATLAB help file, you will find the full list of all the colors that are available. So there's a few syntaxes for them that creates each color. When you want to plot using a specific color, so you plot once again your x, y, and right after that, using quotations, you put in your argument in here. Why we call it argument is argument can be colors, it can be the size of the line, so the thickness of the line, it can be the data points. So there's a number of things that you can play around with the way you create your plot. You can plot it as dotted lines, etc. So here's some list of what we call the data markers, line stars. So the data markers will obviously create just at your data points. It will put either circles or squares, etc. Very similar to how Excel will do it. Although in Excel you have the right click and you can go to figure or line properties and select the size of the line. You want to select the style of the data markers, the color of the line, you can do that. So this is how you do it in MATLAB. So for example, plot x, sine x, and you have as an argument, so r asterisk semicolon, it will plot it like a red dotted curve and asterisk markers. Doesn't really matter which order you put them in. Okay? It will just plot all the arguments that you have there. If you have 3 arguments, it will go and do all these 3 arguments. So don't worry about this. For exams and all, you don't have to remember all of these. So all of these will be given to you in the equation sheet for the exams. All you need to know is how to use it. So how to write the code that will actually do it. So you need to remember the syntax. But that again, by the end of the semester, you would have done this so many times that it should be second nature. Because from next week onwards, it's almost that every single week lab you will end up plotting stuff. Because that's the easiest way to represent data and to show answers. So again, this is just some examples that we have from T0 to 360 degrees. So notice here, the graph that we have for sine and cos, they are not very smooth. Why is that? Yeah? Exactly. So you can see here, what we are doing is we are doing 0 in increments of 30 to 360. So we only have, X amount of data points. When MATLAB is plotting the data, all it's doing is it's joining the 2 points. So if you don't have enough data points, MATLAB will join them using the straight line, and you'll see that it's not a very smooth curve. To fix that problem, you could change this. So you can make the increments maybe 10. This will make the curve a bit smoother. Given that you are not the one doing the calculation, nothing prevents you from doing that. Okay, that's why you bought the computer, right? Let it work. So you can use any amount of numbers that you want, but remember, the more data that you use, that means you have larger matrices, which means you end up with a longer computational time. Fortunately, with the computers nowadays, even these commands, they'll probably be done in like a second or so, because the computer is too fast. So now that we sort of know how to plot a graph, so we can represent multiple curves on the same graph, we can plot them different colors, we can show different data markers, different line styles, etc. We still want to make the graph in such a way that when someone looks at it, they know which one is which. For instance, in this one here, if I didn't tell you that, how would you know which curve is the MATLAB sine and which one is the approximate curve? So what we need is to add some labels to the plot. So on a basic plot, you have a few labels. So you have the obvious one, the title. So the syntax for it is simply title, and using the quotation or apostrophe quotation marks, you can write anything you want inside. So that will appear as the title of the graph. You want to put some X labels and some Y labels. The syntax is X label and Y label. Again, round bracket, you have the quotation marks, and anything you write in between will appear onto your X-axis. You can add the legend, so to know which, if you have, that's especially if you have multiple curves. So you want to know which one is which. So you have your syntax, and the way it will work is, when you plot, so for example, if you plot x comma y, comma, I don't know, t comma v, and then let's just say t comma z. So what you're plotting here is 3 sets of data. So you have 1, 2, and 3. So the order of the legend will be the same order as the way you plot it. So the first one will be that, second one will be this, and the third one, whatever else that you add. Okay, so they follow the same order. You can also show grids. So you can turn grid on or grid off. So it's simply using the command grid on. So what that will do is create a plot, and it will turn the grid on the plot. Okay, so let's just have a quick try. So x equals to, I don't know, let's say 0 or negative 1 to 1. Okay, y equals to sine of x comma y. Okay. My computer is a bit slow. All right. So then you get your graph. So actually, I should do that into an M file. Let's just do it quickly. Okay, so in this case, what I'll try to do here is just create a plot, but just put the X label on it. Okay, so you can see that the plot comes up with the X label that shows the X values. So once again, I won't run through the whole example of doing the title, etc., but you can just see how it works, and you can try that. But you'll see in your lab, this next week's lab, there will be questions about plots, and it will also tell you to remember to label your plots. Failure to do so will result in mark being lost. Okay, so keep that in mind. So in your case, if you forget to label a plot, okay, you will probably lose maybe 1 mark. 1 mark is worth 0.2% in your final mark for the unit. Nothing weird is going to happen. However, someone who's not sort of used to labeling plots, 1999, NASA lost $125 million in the Mars orbiter. The satellite crashed into Mars, and the reason was NASA uses metric units for everything. The Lockheed Martin, the company that was controlling the satellite on a day-by-day basis, was working in imperial units. So basically, they were comparing apples with oranges. So, well, I suppose this is a good lesson. If ever you're working for NASA, don't do the same mistake. So when you have, so now that, short while ago, we looked at some inbuilt functions that were designed or created specifically for matrices. You do have some built-in functions that are specifically created for plots. So the first one, so again, if you recall from last week, we had the commands clc and clear. Clear will clear all your variables. clc will clear the command window. We have a new command now called close all, and this will close all the open figures. If you're writing a program that has 10 different plots, and then you have a program after that that's going to again create another maybe 5 or 6 plots, so it's quite handy to use close all. So before you run your task, you close all the open figures. You have hold on and hold off. So what hold on and hold off is to reuse the last plot without erasing it. For example, you're writing some lines here, some commands, and you end up with plot, comma y, and then you're continuing writing your code, and then later further down or something, you end up with another plot, maybe t comma v. If you wanted them to all be on the same plot, one of the options would be to have plot x comma y comma t comma v. So then everything will be on the same plot. However, to do that, you have to wait right until the end to write it down. But what you can do is, you can write it, it's only about 5 more minutes. So if you want to do it still in the same order, so you want to have your plot and then you want to continue your code and have your plot again, you can use the command hold on. So you have plot and then hold on. So what it will do is it will plot x comma y and then it will just hold the graph. You continue writing. When you have plot t comma v, it will plot that onto the same graph. But you need to remember afterwards to do hold off. So it releases the plot to you. Otherwise, it's just going to keep holding on and not plot anything. You can also do multiple plots in one figure. So you can have, for example, a situation whereby you want to represent a few sets of data, but you want to show everything on like just one figure, but you want 4 individual plots. So this is where you get better than Excel. Okay? So it's a bit easier to do in MATLAB. The command for this is subplot. Come on, guys. It's Friday. 5 more minutes. So if you want to do multiple plots on the same figure, you use the command subplot. The syntax is very similar to a matrix. So effectively what we are doing here is we are creating a matrix that will contain a lot of little plots. So the matrix that we create, so rows and columns, and then we specify the index. For instance, okay, let me do this first. Okay, so instead of writing plot, so you'll be noticing a few things the way I write code, so you can feel free to copy it. Actually, plagiarize it. No. So if I do subplot x comma y, sorry. So I want to create that plot of x and y into just a small subplot. So I can have subplot, for instance, let's say we want 2 rows and 3 columns, just for the sake of it. And index is 1. So 2 rows, 3 columns. In the first location, I want to plot x comma y. So when we run this, so you notice that like I get a figure. So it looks like I could have fitted 2 more on the top row and 3 more at the bottom. So that will be my 2 rows and 3 columns. So now if I move it to index 2, so you see how like the graph has moved to the second, like the first row but the second column. So this is handy if you want to plot multiple figures on just sort of one graph. So then you can represent all your data together. You can also set your axis. You can set your axis from, you have x minimum and x maximum, y minimum, y maximum. Because you'll notice that when you plot a graph in MATLAB, it will automatically set the axis limits for you using whatever default it has. So based on your data, it will set those limits. However, if you want to set your limits to be anything that you want, you can force MATLAB to set the axis on your plots. So all these here, they are just little inbuilt commands that will help to make your plot look better. So it's more into how you're presenting your data, more so than actually doing the work. Not yet. So there's a quick question for you. On a quick glance, so your first debugging task, what's wrong with this code? So these are quite handy. Because remember, when you go to exams, you won't have MATLAB there. However, you could get questions like this. Here's a code. Fix the mistakes. Sorry? Yeah, so you have one mistake here. Yeah. Yeah. So I won't tell you where all the mistakes are. So have a play with this. You can write it down, plot it. If it doesn't work, go back and try to fix it. So then we have a bunch of 3D plotting functions. Now, with these ones, we'll just go through them very quickly. It's just more so you know that they exist. 3D plotting is not really examinable, but it's quite handy for yourself to know in the future, because you might end up plotting either 3D lines, mesh, surface, or contour plot. There's just a bunch of commands that they use. But what that does is you can get cool graphs that looks like this for a 3D. A mesh plot would be something like that. So this is handy if you're trying to plot the elevation on a property. So if you work for a company that you're doing elevations, you can plot the topography of a land using mesh plot. You can do contour plots as well. Okay? So again, you have a bunch of help paths that you can go through, thank you, that you can go through in your own time to see what are the different syntaxes and how to use the various plots. And again, don't forget, all these plottings and all is very important because that's the way that you represent data. It will be very useful for you for this semester. All right, guys, so that's it for